Good morning, students. Today we are discussing about the reactions of alkenes, that is, the electrophilic addition mechanism of alkenes. In alkenes, the main reaction is electrophilic addition that we are discussing in this class. So, mechanism. Generally, a reaction in which two molecules combine to yield a single molecule of product is called an addition reaction. You can see a simple reaction here. The addition of a reagent, that is YZ, yields a product, that is the double bond is broken and the product is formed. Acidic reagents that are seeking a pair of electrons are called electrophilic reagents. Electrophilic, that means philic means loving. So electrophilic means it is electron loving species. Electron loving means they have the tendency to accept electrons. That is, positively charged atoms have the tendency to accept electrons because they are electrophilic. And how do you know what is nucleophilic? Nucleophilic means nucleus loving. That means they are rich in electrons and they have the tendency to donate electrons from itself. That is nucleophile. So here we are discussing about electrophilic addition. So electrophiles are positively charged and have the tendency to accept electrons. They are electron deficient species also. So the first is mechanism involves two steps. You can see the two steps reaction in this picture. So first reaction means the addition of the reagent. HZ is generally we are noting the reagent like HZ. HZ examples are HCl, HBr, HI, H2SO4, H3O+, etc. These are the examples. In the first step, the double bond is broken and the hydrogen, the positive part, is added to the reactant. That means one carbon. And the next carbon is seeking a positive charge. That is, it is converted into a carbocation. So that is the first step. It is a slow step. So that's why the intermediate formation is there, because it is a slow step. So I think in earlier even-E2 reaction also, even reaction contains two steps. One step is intermediate formation of carbocation, and that was also a slow step. Here also the same type of mechanism is there. Here the reactant is alkene and the double bond is broken and first it forms a carbocation. That is the first step. In second step, that is the second reaction, the Z, that is the the negative part. So in HZ, H will be the positive part and Z will be the negative part. The negative part is added to the positive charged carbon, that is the carbocation, positive charge containing carbon, and forms the product. You can see the product. The result will be chloride, bromide, iodide, HSO4 minus H2O, etc. So this step will be a fast reaction. So this is the general mechanism of electrophilic addition in alkenes. So one more explanation. Step 1 is the transfer of hydrogen ion from Z to the alkene to form a carbocation, that is a transfer of a proton from one base to another. So proton is transferred from, proton means it is hydrogen, that is a positively charged. The transfer of proton from the reagent to the doubly bonded carbon, and it is attached, and the next carbon is converted into positively charged carbon. So once again the reaction is shown there, electrophilic addition mechanism. So step 2 is the combining of the carbocation with the base Z. The eliminated base will react with the carbocation to form the final product. So that is the mechanism of electrophilic addition. So here is some examples of that mechanism in various electrophilic addition reactions. First one is addition of HCl. You can see the two steps in that reaction and final formation of product. Second reaction is the addition of sulfuric acid, and third reaction is the addition of hydronium ion. So you have to write these reactions and you have to study any one of this example. Maybe the first example is easiest for you, that you have to study. Remaining two reactions you have to understand. Next is reactions which involves the electrophilic addition. Examples of various reactions of alkenes. First one, addition of hydrogen, that is catalytic hydrogenation. You can see hydrogen is added in the presence of platinum, palladium or nickel catalyst, and an alkane is formed. In this example, propene is converted into propane. So propene, the common name is propylene. Addition of halogens is the next reaction. So this is a general reaction and a dihalide is formed. So example, propene is converted into 1,2-dibromopropane. So next is addition of hydrogen halide. You can see the reaction HX. A alkyl halide is formed as a product. Propane is converted into 2-iodopropane. So in this reaction, you can see some more explanation like addition of HBr. It yields two kinds of products, that is in presence of peroxide and also in absence of peroxides. That is based on a specific rule and it is known as Markovnikov addition rule. So about the explanation of this rule that I will discuss in the next class. Now you just see the reaction is like this, and the explanation I will give you in the next class regarding Markovnikov rule and its orientation. What is that? So generally, this electrophilic addition is based on Markovnikov rule. So one rule you have studied in E1, E2 reaction, that is Seisov rule. So this is different from Seisov rule. It is a different rule. Next is addition of sulfuric acid. You can see the reaction and the product. Example, propene is converted into isopropyl hydrogen sulfate. Next is addition of water, that is hydration. You can see the example also. An alcohol is produced. Next is halohydrin formation. In that halogen and water is added and we will get a product commonly known as halohydrin. Here you can see the example. Propylene is converted into propylene chlorhydrin. And next one is dimerization reaction. Dimer means it is the polymer. That is same molecule of a component. Here you can see the example. Two molecules of isobutylene is combined together to form a dimer, that is 2,4,4-trimethyl 2-pentene. These two monomers attach together to form a polymer, that is dimerization reaction. Two products are possible. This is also an example of electrophilic addition. Next is alkylation. An alkyne is added and a bigger alkane is formed. Alkene is converted into alkane by the reaction alkylation. You can see the example. Next is oxymercuration demercuration reaction. Here alkene is added with mercuric acetate and water and a product is formed. It is based on Markovnikov addition. Here one example. Hydroboration oxidation is the addition of diborane. Alkyl borane is formed. This on oxidation is converted into an alcohol. So here two examples are there.